All right, ladies and gentlemen, we'll go ahead and get started with our first talk. I'd like to introduce Ben Schmitt and Ryan Walker from Douala. It's going to be talking about Canaries. Thanks, guys.
All right, we're going to get this one off. Thanks for being here. So I'm Ben, and Ryan, as Brandon said, I work at Douala. We like to solve hard problems. One of them is how do we make sure we know what our adversaries are doing, be it a pen tester or a real adversary. So this is one of those things we do, which I think is kind of fun.
Hello, I'm Ryan, IT Security Specialist at Douala, and I will be going with Ben through these slides and going over what a canary is and what it does and what it can be used for. So how many people have heard the phrase canary in a coal mine? Okay, most people, surprisingly. Basically, for those that don't know, miners needed a way to know if there were dangerous levels of carbon monoxide or methane gas leaks in the mines. So they would take canaries in cages down in the mines with them as an early detection that there were these leaks. So the canary would die, and then they would know that they have a little bit of time to get out before the levels get too dangerous for the miners themselves. And that's kind of what canary is. It's a way, it's an early detection that somebody is doing something that they shouldn't. It's a diverse honeypot that can be deployed in minutes. We'll go over the deployment process. They have physical devices, which we have right here, as well as virtual devices, and we'll go over those. And one important thing to note about the Canaries is that it doesn't use vulnerable services as a way to alert upon or entice hackers. It's more of uses enumeration detection as well as normal interaction with the services that the Canary is hosting.
Thank you. So Ryan said enumeration. So I put myself in the mind of an adversary or a pen tester. You somehow get credentials, you're on a network, you either elevate them or not, and then you're probably going to go ahead and look for like an SMB share, a backup system. You're going to screw around. So if you saw an SMB share that was called like Douala_R&D, you're probably going to want to see what that is and profile it. That's an example of what a canary can do. So why are these things cool? You can deploy them really quickly. I've been into these types of deception techniques since 2004. Anyone ever read the old Know Your Enemy HoneyNet project book? Maybe not. I'm dating myself. They talked about honeypots, but they were not managed back then. It was a real pain in the ass to set them up, monitor them, and make sure you didn't screw things up. And then unfortunately they got a bad rap because a project called CBEC came out, which was a kernel mode rootkit. So you could see what the attackers are doing. People said I can detect it, and this kind of went away. Well, honeypots are coming back in a big way, and we think deploying them in a managed way could be a good thing. The signal-to-noise ratio is probably going to be in your favor. So who here runs a SIEM that's full of data? Or at the edge of your network, you're seeing people run the AccuNext scanner against your edge. Chen and I see that garbage in our logs all the time. So how can we get an alert that has higher fidelity? Well, this one has pretty high fidelity. Either there's a misconfiguration, you're having a pen test, or an adversary is doing something, and then you can respond to it quickly. So because adversaries. High interaction honeypots are a lot of work, basically building a full-on server that emulates, I don't know, setting up a full Nginx server. Takes some time, takes care and feeding, you might forget about it. And a low interaction honeypot, like a Perl script that listens on a port for telnet, isn't very interesting. It's not going to respond to an nmap. You're going to see the operating system. So we think that this is a nice, happy medium. And then Thinkst is the one we're talking about tonight. Haroon Mir is kind of the CEO. His talks are really good. I recommend you check those out sometime. He's pretty interesting. I'll call it thought leadership at the risk of you laughing at me, but check those talks out.
So this is just a list, not all of them. There's more, but just kind of going through like the different categories that a canary can emulate is like Windows servers, Windows endpoints, SharePoint, Linux standard servers, proxy database. It can emulate Cisco routers, Dell routers, hypervisors, as well as NASs. And if you're in like industrial PLCs, you can also emulate. One thing to note is that these are always changing. And I think this week they just released Windows 7 and 2003 support, Server 2003.
So Ryan will show you what the hardware box looks like in a little bit, but it's custom hardware. I don't know what's under the hood, and we're not going to hack it and find out. That's not the point of today's talk. Whether it be a Pi or probably some customized hardware, and that's what's theorized. when you nmap this thing, it'll emulate the MAC address and emulate the services really well. So the hardware is customized to not be a piece of garbage. Like, it looks and feels like an adversary would hope it to look and feel. RDP is not listening, by the way, which is kind of cool. We'll talk more about that, but RDP is a custom protocol. Pretty hard to emulate that.
Yeah, so how do you set one up? So they have an AMI that they share out through AWS, and it's as simple as launching an instance with that AMI selected, as well as, you can use CloudFormation to stackify it and automate through code the deployment of the Canaries. For physical Canary, you just have to plug it in the network, power it on. The blue light will turn on the Canary, and then you actually connect to it to Bluetooth. You go to that URL up there. You configure the Canary out to what you want it to be initially. You then register it and then approve it through the console, saying that it's active. So it's pretty easy to set up. One interesting thing is how does it actually contact the console? And it's all UDP 53. This is an example of like PCAP's SPI information. You can see in the bottom left-hand corner, that's ICMP from the Nmap scan. After it hits the Canary, the Canary does a reverse DNS lookup on that IP, and then starts sending data out to the console. We believe it's encrypted, or at least encoded, but it's both. And so everything, you don't have to open external ports for it to communicate with the console. It's all through port 53. Same thing with configuration. If you want to configure something, it'll push out those configurations through port 53. Alerting, there's several methods of alerting. You can do SMS. You can do it within the console. Also email, this one's email. And then you can set up webhooks through like Slack, HipChat. Also, they have a generic, so if you want to integrate it with something else. The alerts are almost real time. So we have some non-live demos for you. I'll go ahead and go through them. The first one is scanning the Canary. So this is what it looks like when you scan. So this is the console. There's no alerts currently. I've run just a Nmap scan on it. We can see some open services. If we go back to the actual dashboard, we can see that it's already alerted 4 seconds ago. And that we can see that the source IP of where it was coming from, as well as the ports. One thing to note is that it actually detects based on non-open ports, so filtered ports, closed ports, and anytime that gets checked against, that's what triggers alert, not the open ports. And there's a way around that, because we'll go through that a little bit later. So then what does it look like for SSH when you connect? Again, no alerts. And then we'll just SSH into it and just try inputting a password. So after the third time, it will just say access denied. One thing to note about this is there actually is no SSH access. There's no way to actually get into the Canary itself. So we see that there's alerts, and we can see that it actually shows what user and password that they tried to use to get into it. One other thing to note is that it will actually capture the public key from the person trying to connect as well. In this scenario, I didn't have a public key to use for my testing, but it would actually show that up there as well. So from the previous scan, it was kind of hard to see. I opened port 9200 as a custom service to emulate something like Elasticsearch. So this one kind of shows like what happens when you interact with a service. So what I did, let's see, is that I have just a curl command, Elasticsearch, post, and to input some random data to Elasticsearch. I can try. Let's see. Apparently I cannot. Anyways, basically it's just a curl post command, and that has a user ID and an amount, just some random input fields. So once you hit enter, it actually won't do anything. You can customize responses, so you can say like error command unknown, but we'll be able to see that that port was detected, that there's interaction. You can see up there that it did a post, as well as you can see that it was a curl command, and you can actually see down below the information that was passed. So you can see what they're actually trying to do. All right, last one is, yep.
This is the exciting one. This is the one I like a lot. So if you're not paying attention, like check this one out. I like it. By the way, I'm holding a hardware Canary. Come talk to me later if you want to look at it. I'm not plugging it in for you to mess with. We can show it to you.
All right, so this one is connecting to Windows File Share. So you can bind the Canaries to a domain, Active Directory, and you can actually have it authenticate. Right now, since it was just a test machine, it wasn't bound, so any user information password, it's not going to return anything, and it's not going to alert unless it was bound to the domain. Since the password wasn't working, I just connected as guest. Then you can actually see there's a folder structure. And then you can actually, I just made a bunch of random junk up. But you can put your own Word documents, own files in there, executables. And then here I saw a file called chen ssn9. And then when you open it, it actually alerts. It's a Canary token, which we'll discuss in a little bit. But it'll say that, hey, this file has been opened. We'll go ahead and just skip this because it takes a little while to open. But this is what the SMB Alert looks like. You can actually see that it's just part of a work group. If it was a domain, you'd be able to see that. You'd be able to see the share name, just named it remote users, as well as who accessed it. It's just guessed, but if it was bound to a domain, you would see which user accessed it, as well as like the SMB name. So where can Canaries be deployed? Physical data centers with the physical Canary. They have AWS Omnis, which we talked about, and then virtual Canaries, which are just VMware images. So far, no documentation that I found or information whether they have support for Google Compute Cloud or Azure. This is just what I was able to find that they had access to or had available.
All right, so we talked about Canaries a decent amount. I think Canary tokens are a cool extension. So these are just files or artifacts you may distribute or sprinkle across some area. Think of this more like a campaign. There's other products that do this, but I think these are really slick. There's canarytokens.org, right, which is free. You can go play with them and make your own Canary tokens. You can also use their API if you have a subscription and do more with them. So as Ryan showed you the SMB share, what if passwords.slxx or merger acquisition targets, what if that were sprinkled across all your laptops or all your endpoints? Like what if you put them on your disabled administrator desktop, which you shouldn't be going to, right? Your users shouldn't be going there. But if an adversary has credentials, they might think that's interesting. What about putting an AWS API key? And these are actual tokens, by the way. If you mess with a QR code, it's a Canary token. We'll get a chirp from it. If you put that AWS key in secret, like, I don't know, on your head of legal's desktop, that no one should ever see that. Like, if that alert goes off, that's a bad day. So this is an example of an alert that you should set that should never go off. So we think Canary tokens are pretty cool, too. It can extend what a physical or virtual Canary can do, and you're putting tokens on your network that can do neat stuff. Some researchers found out recently that Chrome was doing some light AV scanning on Windows hosts because they had Canary tokens, and when Chrome started inspecting them, they went off and chirped. So these things do work, and I think they're pretty neat.
Yep, and one thing to note is like with the AWS keys, you can actually see what commands they ran, like in the AWS API console. So you can see what they're doing as well. There is about a 15-minute delay on that one, though. But other than that, there's like S3 buckets that you can create, Google Docs, things like that. So with the Canaries, there are some opportunities working for them with a short time that would actually really help. One of those things is more a thing to note is in AWS security groups. You pretty much have to configure security groups to allow traffic to non-open ports. Otherwise, how the Canaries detect network scans is it looks at the first SYN packet. So if the security group is blocking the traffic to even get to the Canary, it won't alert. Another thing is the API functionality and documentation. It's very bare bones, and the documentation isn't well documented, I would say. So it's a lot of trying to figure things out on your own. So as more functionality is released and their docs get better, it would add a lot of benefit. And then token automation. So we want to automate deploying these tokens. And due to the API functionality, the limited functionality, it's hard to do that. So we're looking at ways to kind of get around that. But yeah. And then our resources.
I think we'll close with this last slide, but I kind of toiled with doing this presentation because the first rule of OPSEC is don't talk about your stuff. So I'm not saying we do or do not have these running. I'm not saying we do or do not use these around the environment. But we think they're important. And I think the risk of someone looking at this and being like, oh, you have Canaries, I think that's low. I think the benefit of the community is there, so I think it's cool to talk about them, even though it might go against normal OPSEC of just being quiet. So with that, I think we're good for any questions you might have. Otherwise, we'll close and catch us for a beer. Any quick questions? Sir. Sean, right? Yeah, no, because we're not there yet. I think we're pretty early on in this. The only one I can talk about is Chrome having the AV engine. Oh, yeah, good call. The question was, hey, what about false positives? We all get them. Have you experienced any yet? And the answer is, and Ryan, you maybe give some more color to this. The answer is not yet. We'll inevitably get those, but we haven't yet. The closest I can share is what I mentioned earlier, and that is Chrome started running AV scans, and they didn't really tell the users on Windows. People started picking it up. That's not really a false positive. It actually worked. But I don't have enough data to share with you. Like, check in with me next Sec DSM. We'll talk more. I'll let Ryan take that one. And can you repeat the question?
Yeah, so the question was, can you whitelist alerts? The whitelisting is very bare bones. It's by IP. And that's something that hopefully, though.
Talk about when you're testing all the scanning you've done. What happens?
So they do have, like, where if there's multiple alerts from the same source, after so many alerts, they'll still report them, but they won't send you notifications until an unspecified cooldown period of not receiving alerts, which I thought was interesting. They didn't really specify how long or how many alerts it takes to get to that point, but it's more of, like, as long as you have that one alert, right, that's all you need. And another thing to note is that like, people ask, can you fingerprint these? And the answer is yes. But by the time that they fingerprint this, they'll have already set off an alert. And that's, as long as it gets one alert off, that's all that matters.
Is any of this at all relevant for home use, or is this really only useful in enterprise? Home use, how would you potentially do that?
Yeah, for home use, I'd use canarytools.org or canarytokens.org. Play with those tokens, sprinkle them around your home network, and test. They're free, they work. You just do it, and I think the email address is all you need to do those. So totally easy. As far as having more of a campaign and testing these, I think that's more enterprise-ish because you can have the free version or the not-so-free version. And the not-so-free version kind of means you need a contract. I would think you're more of an enterprise then. But use canarytokens.org or look at the resources on this slide to learn more about how you can play with them. So the question was, how do you scale this? So the answer is automation. So if you have an AMI or n number of AMIs and you have automation using CloudFormation and stackifying it, use your existing CI/CD pipe to automate the deployment of these use as many as you want or are licensed for. As far as the tokens go, we're still solving that. As Ryan mentioned, the API to hit and get a token and put in what's called a memo field, get the token back and then place it somewhere is a little bit clunky, so we're writing a wrapper to maybe automate that. So it's part of the build process. We've not scaled that up yet, but that's something we want to do.
And the reason why it's so hard to automate is because the only identification other than the IP, the public IP for the tokens, is in the memo. So if we put it, say, on Chen's laptop and it gets triggered in the same tokens on multiple laptops, we'll only be able to see the public IP. So it doesn't specify that it was on Chen's laptop. So we have to automate each individual token in the memo to say where it is, what it is, and that's the problem, right? That with automating it right now.
To your earlier point about automating, like I can just go start the Omni and let it run and just like walk away. We classically think you should automate everything because then what's not automated is rogue. So we've taken the time to scale this via automation. Talk to me offline on a little more how that's done, but that's more of an AWS flavor. If you're doing it inside your own data center, your VMware shop, I don't know, we haven't done that yet. All right, we're going to wrap it up. Thanks for listening.
Thank you. All right, so we're going to take a short break in between talks. Ryan Roast is going to be up next, doing an introduction.